Alrighty, now we're going to do example 4, where we're going to deal with projectile motion. So, ignoring air resistance, the range of a projectile fired at an angle theta with the horizontal and with the initial velocity v naught feet per second is given by this. So r equals 1/16 times the initial velocity squared, v naught, times the sine of the angle of the projectile times the cosine of the angle of the projectile. R is the horizontal distance in feet that the projectile travels. So a football player kicks a football from the ground, from ground level, with an initial velocity of 80 feet per second. Okay, so we're saying v naught is given as 80 feet per second. A says, rewrite the projectile motion model in terms of the first power of the sine of a multiple angle. So rewrite the projectile motion model in terms of the first power of the sine of a multiple angle. So, how are we going to do that? Well, we've got sine and cosine, and if we're able to get a 2 in here, then we can use a substitution. So how do we get a 2 in here? Well, we could take a 2 from here. Right? Well, not really, but if I just put a 2 in here, right, I have to offset it by dividing by 2. So if I multiply by 2, I have to divide by 2, right? So in other words, if I do this, so I can rewrite it as r equals 1/32 v naught squared 2 sine theta cosine theta. Now I've got that, right? So now I can do something with that because we can use the double angle formula. And the double angle formula, I can rewrite this as sine of 2 theta. So r equals 1/32 v naught squared times sine 2 theta. Okay? And so now we've rewritten the projectile motion model, I should say, with a double angle formula. Now it says B, at what angle must the player kick the football so that the football travels 200 feet? All right, so now we want the ball to travel 200 feet, so that's 200. And we know the initial velocity he's going to kick it at is 80 feet per second, so we're going to do 132 times 80 squared times the sine of 2 theta. Okay, so now I'm going to solve this. So this is going to be 6,400. So this is going to be 200 equals 6,400 minus 32 sine of 2 theta, right? Well, this is cool because this gives you 200. 6,400 divided by 32 is going to be 200. So it's going to be 200 equals 200 times sine of 2 theta. And so sine of 2 theta is going to equal 1. Well, when is sine equal to 1? Sine is equal to 1 at pi over 2 and 3 pi over 2. So that means when 2 theta equals what? Pi over 2 and 3 pi over 2. Which means when theta is equal to pi over 4 or 3 pi over 4. Right? Now, here's the thing. Only one of these answers makes sense, right? Because 3 pi over 4 is 270 degrees, right? Well, 270 degrees would be going the other direction. Even this one here, 3 pi over 4, again, it's going the wrong direction. So this wouldn't be a good answer. 45 degrees is the right answer, pi over 4. Of course, we would say, okay, he's going to have to kick it at a 45-degree angle so that the football goes 200 feet. Now, the question then asks, now this is a checkpoint, so I'm going to just do it in the same video here, because and for the checkpoint it says, in this example, for what angle is the horizontal distance the football travels a maximum? So it says, for what angle is the horizontal distance the football travels a maximum? So, the way you would find that is that you go back to this, right? So let's go back to this. So R, we want to find R equals 200 sine 2 theta, right? So what you would do is on your calculator, you would graph this equation. You graph that formula. And what you're going to do is then it's going to be a curve. It's going to be an arc for R. And what you're going to do is adjust your window. And then what you're going to want to do is use the second calc option on your calculator if you have a TI-84 or whatever. And then you're going to choose max. You're going to go down the menu and choose the one for maximum. And it's going to ask you to choose a left boundary point and a right boundary point of where you think the maximum is, and then a point in between where you think the maximum is, and then it's going to calculate the maximum distance, right? So, but what you're looking for, it's going to give you that maximum distance, but it's also going to give you the corresponding angle for this. Now be careful. It's going to give you for 2 theta, right? So this is your x value on the calculator. Okay, that's going to be your 2 theta. Okay, so what you're going to do is you're going to have to take whatever that value is and divide by 2 to get theta. And that would be the angle to get you the maximum distance. All right. Let me know if you have any questions. Bye.